Question number 77. This is solving from June 2020 mathematical science paper. A quadratic form Q of xyz over R represents 0 non-trivially if there exists ABC, which is an element of this R3 space, say punctured at the origin, such that the Q of ABC is equal to 0. Then which of the following quadratic forms Q of xyz over the real space represents 0 non-trivially? We have to find. So the first option is given that Q of xyz is xy plus z square. So Q at, if we put the value of xyz as 1 minus 1 1 minus 1 plus 1 is equal to 0. So Q represents 0 non-trivially in this case for this quadratic form. So option 1 is correct, right? Q represents 0 non-trivially. So what is the option 2? 2 is given that Q of xyz is equal to x square plus 3y square minus 2z square. So if we put Q of 1 comma 1 comma root 2, so it will be 1 plus 3 minus 4 equal to 0. So it is also, this Q represents 0 non-trivially, so in our case the option 2 is also correct. So let's check with option 4 first. Q of xyz x square plus xy plus z square. So if we put Q xyz as 1 minus 2 1, it will be 1 minus 2 plus 1 equal to 0. So option 4 is also representing 0 non-trivially. So option 4 is also correct. Let's check with the option 3 now. So in 3 it is given that Q of x y z, it is x square minus xy plus y square plus z square, right? So if we put equal to this equal to 0, so and you can just x square minus 2xy plus y square plus of xy plus z square equal to 0. We can write it in this manner, and it will be nothing but x minus y whole square plus z square it will be equal to minus of xy. So this term is non-negative. X minus y whole square, it is non-negative. Z is also non-negative, so minus xy is also non-negative. So all the terms here are non-negative, but Q of x y z is equal to 0 only when x y z is at the origin 0 0 0. So here the Q doesn't represent, it's not representing 0 non-trivially, right? So option 3 is not the correct option, so we have only option 1, 2 and 4. Question number 78 is saying that let Q of xyz be a real quadratic form. So which of the following statements are true? So here we need to check the linearity in the first variable for the real quadratic form, right? So if we consider that, let us check with the first option, this Q of x1 plus x2 yz. Can it be written in this form? Q of x1 yz plus Q of x2 yz. So we can write that Q of, if Q of xyz is x square, then Q of x plus x1 plus x2 yz, x1 plus x2 whole square, and Q of x1 yz is nothing but x1 square, and Q of x2 yz is nothing but the x2 square. So this is not equivalent, so it is not linear in the first variable, so option is 1 is not correct. Okay, let's next check with option 2. So the quadratic form is given that suppose Q of x y z is equal to a of x square plus b of y square plus c xy. Okay, so in the option 2 we have the Q of x1 plus x2 y1 plus y2 0 plus plus Q of x1 minus x2 y1 minus y2 0. So if we put that the value in this manner, that a of x1 plus x2 square plus b of y1 plus y2 square plus c of x1 plus x2 y1 plus y2 plus, now this term will come, a of x1 minus x2 square plus b of y1 minus y2 square plus c of x1 minus x2 and y1 minus y2. So if you simplify it, so what will, so both of the x square, so you will get that 2 of a xn square plus b of y1 square plus c of x1 y1 plus 2 of a x2 square plus b y2 square plus c of x2 y2, right? We will get this, so which is nothing but equivalent to 2 of q x1 y1 0 plus 2q x2 y2 0. So for which this option 2 is the correct one, right? Now check with the option 3. So for x2 y2 z2, if we consider as 0 comma 0 comma 0, then q of x2 comma y2 comma z2, it is also 0. Then, right, so then q of x1 plus x2 is given y1 plus y2 z1 plus z2, it will be nothing but q of x1 y1 z1, right? which can also be written as q of x1 plus, not plus, it is x1 comma y1 comma z1 plus 0, which can be written as q of x2 comma y2 comma z2, right? So option 3 is also the correct one. So it can be represented for at least one choice of x1, x2, y1, y2 and z1, z2. So let's check with the option number 4. So let us consider that q of x, y, z is equal to z x square, and whatever it is given over here, that 2 of q x1 plus x2 y1 plus y2, this one. So 2 of q x1 plus x2 y1 plus y2 comma 0, and 2 of x1 plus 2 of q x1 minus x2 y1 minus y2 comma 0. So let us consider this as equation 1. So equation 1, we can write it as 2 of x1 plus x2 square plus 2 of x1 minus x2 square, right? So it will be x square is there, so it will be nothing but the x1 square plus x2 square, which is not true in general. So option 4 is also an incorrect option. So in our case, only option 2 and 3, these are the correct option. 2 and 3.